let's move on to another issue, and that's that Mr. Toth dealt with the Pioneer anomaly problem. And you had Pioneer 10, you had Pioneer 11, and they were sent out in the 70s, early 70s, and they eventually left the solar system. Okay, and sometime about 20 years after they sent them out, a little over that, they realized that they took some data and they said, hey, the probes are not where they're supposed to be. They're supposed to be farther out into space, and one of them, I don't know, both of them, were like 300,000 kilometers closer to the sun than they should be. And that's the distance from the Earth to the moon, roughly. And that's not a big distance in the context of the universe, but it was a measurable distance. They said this probe should be farther out. Okay, and so one fellow who was in charge of the program, Anderson, he wrote a paper and he said, we looked at everything and we can't figure it out why that thing is not farther out where it should be, where it was calculated to be, why it's 300,000 or so kilometers closer to the sun. Something is pulling it back, or it was kind of decelerating towards the sun. It wasn't accelerating at the speed, at the rate it should have been accelerating. That was the issue. And so one guy, name is Murphy, he wrote a paper, okay, and he said the following. He says, Anderson et al. Have recently modeled the acceleration acting on Pioneer 10, 11 Ulysses Galileo spacecraft. They find an anomalous excess acceleration of blah, 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 directed towards the sun. So there was a deceleration, in other words, towards the sun, right? It was, the probe was not running away fast enough. They have ruled out excess gravitational forces due to the galaxy and unidentified planetesimals, errors in the orbital rotational parameters of the Earth, spacecraft gas leaks, and errors in planetary ephemeris as explanations for the acceleration. In addition, the authors rule out, this is an important one, radiation pressure from thermal radiation generated by the spacecraft radioisotope thermoelectric generators, in other words, RTGs. Okay, and so they couldn't figure it out, and they said, but the important one is they ruled out this thermal radiation, okay, the heat that the probe was apparently spitting out, preferentially in one direction. And so what this fellow says, well, the assumption was wrong. The assumption was that this heat was being spit out isotopically. In other words, it was uniformly spread out. And this fellow was arguing that, no, it was really in one direction. And that direction happened to be the direction in which it was traveling. And so that served as a, kind of like a damper on speed. Okay? That's more or less what this fellow was saying. And that's the idea that these folks who took over the investigation of that problem concluded. It was like a foregone conclusion. That's what they were trying to prove. And it turns out that's what they proved. And it's this fellow. He's Russian. Name is Turyshev. And you can see Mr. Toth's name right next to his. Okay. And they published this article in 2012, about 14 years after the problem was discovered. And so what did they find? Well, they say the anomalous acceleration of the Pioneer 10 and 11 spacecraft is due to what? To the recoil force associated with anisotropic emission of thermal radiation off the vehicles. Okay, we constructed comprehensive finite element thermal model of the two spacecraft. Then we numerically solved thermal conduction and radiation equations using the actual flight telemetry as boundary conditions. So they went in there and essentially, this is the notion that they had, that this probe was out there spinning in one direction of travel, and because of that that heat it was dissipating, that slowed it down. That was the notion that they had. Okay, and that's what they published in their physical review letters there. Okay, so this is where they started. This is how they concluded. They essentially had already a theory, because the theory came from 1998, and these guys published 2012, 14 years later, and they say, oh, by the way, we proved that theory. That's essentially what it was. How did they prove it? They went in there and looked for data. They crunched data, for several years, and then they came out with their conclusions. Okay, so this is where it stands, because some people criticize that. They said, well, it's more or less the case of the fox guarding the chicken coop, because these guys were the ones who ran the project, and then it's more or less like guys who investigated the solution to the problem. They said, we found it. Yeah, okay, maybe, it could be. Some people criticize them. Here was one guy, Paul Ten Boom, nice name for a group. Ten Boom. And he says this paper discusses the likelihood of whether the Pioneer anomaly is due to mundane systematic errors effects or indicative of new or unappreciated physics. See, again, the issue here was whether there was new physics, whether we had to change the gravitation equation. And it turns out that in this case, Toth, Mr. Toth, he went in there and he said, look, in this case, we're going to say that the equation is correct. What's wrong is the heat inside the probes. But in the case of dark matter, he's getting away from dark matter and choosing the equation. So it's interesting that he had that change of heart, you could say, or change of tactic or strategy. And he said the main aim of this paper is to argue that recent publications suggesting that the anomaly is previously overlooked thermal recall forces, which is in stark contrast to the earlier consensus, 98 to 10, are open to questioning. Okay? So, some people, even to today, there was a paper in 2020 that also criticized this, at least one that I read, that criticized the pioneer anomaly conclusion. Okay, and again, a lot of people say there's new physics going on, and I agree. I'm going to show that. Okay, yeah, there is new physics that these people are not aware of. Okay, so what happened was you had the Planetary Society. They had to give these people money, funds to do the research, and that's what they did. And here you have it. It says the only way to solve this mystery was to look at much more data than had previously been available. So they're saying that the Anderson group, the original group, well, they didn't have enough data and they didn't really do the research properly, scientifically. And this guy Turyshev, he came in there and he pulled all this data out that was about to be canned, by the way. So he saved it just in time, and they needed some money, and so the money was provided by the Planetary Society. And it says that is where Planetary Society members stepped in. A few years ago, Slava Turyshev and his colleagues at the Jet Propulsion Laboratory were in desperate need of funding. Okay, to help them do just that. With funds supplied by our members, Turyshev successfully chased down data from a number of sources. And what? He says, Pioneer's anomaly solved. Case closed, sweep it under the rug. Okay, that's how they solve problems in mathematics. Yeah, they put an end to it. They said, no more discussion. We figured it out. Don't talk about it again. How do we do it in science? Okay, well, if all atoms in the universe are physically interconnected, we have a different universe, and especially we have a new notion of gravity at greater distances. That's where the problem comes, okay? At greater distances, we should, what do they call it in mathematics? Prediction. That's what they do in mathematics. They call it predictions. We can predict, retroactively. We can predict the origin of the universe, all that kind of stuff, right? The Big Bang, conditions in the Big Bang. Okay, we can predict that dark matter and all this stuff is going to behave a little differently, okay? Why? And here you see it. This is a notion of Newtonian gravity, okay? It's the notion of square of the distance. And we all learned this by rote in high school. It's been proven, certified, it's a done deal, okay? So this is the square of the distance. What do I propose? What is the rope hypothesis proposed in exchange? Well, here it is. We propose the bird's beak. We're saying that what Newton's equation only is for a certain distance. That's where you have that triangle there. But the further out you go, the ropes that connect every atom in the universe coming out of the sun. This is the sun, and of course I didn't put the planets in there. What you have is at some point they should produce that curve, okay? And we're going to see in a minute here how that changes gravity right at this edge of the solar system, okay? So let me remove this, and let me show you this, one versus the other, so you can see it side by side, or up and down. Okay, so this is the difference between them. Okay, you see the square of the distance versus the bird's beak, as I call it. Okay, and that comes from the assumption that all atoms are physically interconnected by the the electromagnetic rope. Okay, two atoms bound by a pair of twine threads. That's what the universe is like. That's the main unit of the universe, I guess you could say. Okay, so where do we go from here? Well, here we have it. Here's the bird's beak. Okay, and here's the sun. And there's that star there, that's Alpha Centauri, okay, nearest star, or Proxima Centauri in this case, right? And so what do we have? We have the bird's beak going from one sun to the other, from one star to the other. So if you start at one star and you take all the ropes that extend outwards, the majority of the ropes, the overwhelming majority of the ropes are going to converge upon some kind of coaxial that holds these two stars together. Okay, so we call that the linear regime that's between them, and there is no gravity, no pull of gravity, no square of the distance gravity in the linear region. Okay, so this is the notion that comes from the rope hypothesis. Okay, that straight line there, that's going to be the linear regime. Okay. Okay, so what's the issue? Now the issue is that there is no gravity as we feel it here on Earth in the linear region. And that's because of the assumptions we make, okay? So it's contingent on the assumption. The assumption is that all atoms in the universe are physically interconnected by a twined pair of threads, the electromagnetic rope. Okay, so let's look at the linear regime and tell you what happens when an astronaut wants to leave the Earth, or in this case, the Pioneer 10s and 11s, okay? So here's the astronaut trying to leave, with his spaceship. He's trying to leave the Earth, and at some point, he's going to go through this linear regime, which is just straight lines primarily, running straight into every atom of his ship, including himself, okay? And so when you look at this, there you have in one direction Proxima and the other one the sun. And when your spaceship tries to leave, okay, the bird speak, the end of the bird speak, well, it's going to slow down. Of course it's going to slow down, okay? And again, you have no pull of gravity, at least from the front. All you have is just essentially going in a straight line, even though that's not exactly like that, but you get the idea. The idea is that the bird speak gives you an idea of how gravity behaves at the edge of the solar system. Okay, so it's a new theory for those of you who are not familiar with it, okay? And so it's based on new assumptions, and the assumptions is that we don't do action at a distance in science. That's religion. Worse, it's mathematics. Okay, religion is still rational to some degree, I guess you could say. Mathematics is all irrational. Why? Because they are moving concepts around. They replace objects, or better yet, they reify concepts and they treat them. They reify concepts and treat them as if they were objects.